Again, welcome to Java programming. In these lectures, we're going to discuss about encapsulation. Again, previously we discussed about how to write a classes. That's a user-defined classes. We talk about what is a class, which consists of two members, the characteristics, which will be the instant variables, and also the behavior or the methods of the class. In this session, we're going to discuss one of the main features of object-oriented programming, which is called encapsulation. And the whole concept of encapsulation is the security of the data members of the class, especially the instant variables. So our main objective again is encapsulation. And here we say that we can take one of the two views of an object. The first is the internal. The internal will be the details of the variables and also the method of the class that defines it. So when we discuss about the internal view of an object, then we are trying to discuss about the instant variables, the characteristics of the object, and also its behavior, which is the method. We can also talk about the external view of an object, which will be the services that an object provides and how the object interacts with the rest of the system. So the whole concept here is that we know what is an object from our previous class, which is in an instance of a class. It's an object. And an object always consists of two items, which is the variables and also the methods. So when we discuss about the internal view of an object, it means the characteristics and also the behavior of the object. The external view of an object is the services that the object provides to other objects or other items in the system. The system here means in the program. Maybe we have a program with more than one class, and these classes may interact. So from the external view, an object is an encapsulated entity providing a set of specific services. And these services define the interface to the object. So here we say one object called a client may use another object for the services it provides. So a client normally will request a service. And also the client of an object may request its services that's calling its method, but it should not have to be aware of how those services are accomplished. So this will be more or less at the abstract level. So any changes to the object state, that is variables, should be made by that object's method. And this is very important. So this is the whole concept of encapsulation. Again, as we said earlier, the concept of encapsulation is security and the visibility of the class data members. So we use something we call the private, public, and protected keywords, which we may discuss that to specify the visibility of the data members. Most important is the data members. We can also have a method also to be only seen by its only class. We may discuss about that also. So we should make it difficult, if not impossible, for a client to access an object variables, which is very, as we said, very important. The variables, the data. So again, the concept of encapsulation is security. So that is an object should be self-governing. Now, an encapsulated object can be thought of as a black box. So the inner workings are aiding from the client. And the client invoke the interface method and they manage the instance data. So here the whole concept is that the data members of the class will be hidden from other objects or other classes. So how do we do that? We use the visibility modifiers. So in Java, we can compress encapsulation through the appropriate use of visibility modifiers. A modifier is a Java reserved word that specifies the particular characteristics of a method or data. So for example, we know we use final keyword to declare a variable as constant, and we have to initialize the variable. And if we declare it constant, it means the data cannot be changed. Java has a 3 visibility modifiers. So we have public, protected, and private. So in order to enforce encapsulation concept in object-oriented programming, we use these visibility modifiers: public, protected, and private. Public means all the data members or all the class members can be seen by other class in the system or in the program. So that's why it's public, which means there's no any security here. All the classes in the program or in the system can have direct access to the class members. Protected means protected comes with the concept of inheritance. So if I have, for example, I have 2 classes, class A and class B. If class B inherits some, let's say, data members from class A, so here class A becomes the parent and class B becomes the child. Or sometimes we use the term subclass and superclass. So class A is a superclass, and then class B is a subclass because class B inherits data members from class A. Now, if I want class B to directly access the data members of class A, then I have to make the instant variable as protected. If I make it private, it means class B cannot directly access class A. So the only way they can access is protected. Now, when I use public, it means class B can access class A. But if I also have class C, and class C is not hasn't have any inherited relationship with class A, it still also can directly access it. So class A, B, C can access each other with public. Public means any class can directly access the data members of any other classes. But protected means if only those 2 classes have inheritance and relationship, then they can directly access each other. Then the most secured is the private. So most of the time in Java, we don't specify the methods, the class methods as private, because methods normally perform a function. So I can use a method in class A to perform some function in class B, or one method can do 2 functions for both classes. But if I make a method private, it means the rest of it can only be used or seen by the class that is defined at or the member. Other classes cannot use it or cannot access it. So encapsulation, most of the time, we enforce it on data members, not the methods. So private means only the class that have it or declare it in can use it or can send it or can directly access it. So here also we said the protected modifiers always involve the inheritance, which we are going to discuss later on. So members of a class that are declared with public visibility can be referenced anywhere, as we said earlier. Can be referenced anywhere means, again, they can be accessed at anywhere in the program. Other classes can have access to it, can see it. So members of a class that are declared with public visibility can be seen or accessed or referenced anywhere in the program. Now, members of a class that are declared with private visibility can be referenced only within that class. So this is private, highly secured. So when we make a member, again, the visibility modifiers, again, as we said earlier, members of a class that are declared with public visibility can be seen anywhere in the program. Again, we're going to do lab on this, whereby we may have a program with at least 2 classes and see how the concept here works practically. So again, here we said members of a class that are declared with private visibility can be referenced only or can be seen only within that class. So private is very good. Private means highly secured. As we said earlier, most of the time, we make the data members of a class as private. The data members of a class as private, which is highly secure. If, as we said, if I make the methods of a class private, means sometimes we want the method to do some work in other classes. But if it's private, then it only can be work, it can do its work in the class that is defined at. So by convention, most of the time, the data members will be private, and then the methods will be public. So public variables violate encapsulation. As we said earlier again, encapsulation is about security, getting your data well secured. So public means there's no need of encapsulation, because any other class, or here we use the term client, any client can modify the values directly. Or if I have 2 classes, class A and class B, and the data members of the variables of both classes are public, it means class B can directly access class A. Class A also can directly access class B data. Therefore, instant variables should not be declared with public visibility. Here also we say it is acceptable to give a constant public visibility which allows it to be used outside of the class. So public constant do not violate encapsulation, because although the client can access it, its values cannot be changed. So public constant, which, as we said earlier in the class, a variable that is declared constant using the keyword funner. First, we have to initialize that variable. And secondly, that value cannot be changed. If we want to change it, we have to come back to where we declare it constant at. Then we can change it. So sometimes we can say that we declare an instant variable as public, but public constant. In this case, is secure, so do not violate encapsulation. One thing we should know is that in the term encapsulation in object-oriented programming deal with security of our data members. So methods that provide object services are declared with public visibility. By convention, always methods are public, but sometimes we may have a method that maybe our goal is that this method will do work only within the class that is declared at. Then we can make it private. But we can see that the keyword here is services. So methods that provide object services are declared with public visibility, which means they can provide services to other clients or other classes. So public methods are also called service methods. A method created simply to assist a service method is called a support method. So a method created simply to assist a service method is called support method. And since a support method is not intended to be called by client, then it should not be declared with public visibility. So we will see this in lab work, especially when we start inheritance topic. Sometimes we may have a method that will provide service to another method. This method are called mostly to service method. This method are called support method. And we can specify this method as private to be secured. So this is the visibility modifiers concept. So we have public and private. Variables always have to be private to enforce encapsulation. When we make it public, we evaluate encapsulation. Then we have the methods. Methods will provide services to clients. So methods that are public provide service to clients, which means provide service to other classes. If I have 2 or more classes, provide service to other classes. And if it's private, then we can use the support other methods in a class. So method that will support other methods in a class can be used encapsulation private. Now, when we talk about this already in our previous object-oriented programming, accessors and mutators, this is a very special methods in every class. Actually, 3 of them, and also constructors. So when I create a class, let's say I have a class named student. If student have 2 data members, let's say student name and the GPA. Now, I can have a method as an accessor method, always to get the instant variables of both the GPA and the name. Then I can have mutators. Mutators will be set to change the values of the instant variable. Constructor, anytime we create a new object, we call the constructor to initialize the object based on the instant variable that is assigned to it. So we may have a constructor with parameters. We initialize it with the parameter set to us. Or if it's a default constructor, then it depends, the initial value of the instant variable is what will be used. So accessors are a special method that always return the current value of the class instant variables or the instant variables. Always return it. Then mutators always can, we call it to change. That's why it's called mutator, to mutate, to change the value. So if I want to set the value to a new value, I will call the setters. Sometimes we use the term setters or mutators. Accessors also we use the term getters. Getters and accessors is the same. Getters and setters is the same as accessors and mutators. So that's what you are. They are sometimes called the getters and setters. And normally by default, we use the name, always the name will start with get. So if the instant variable is name, I can name it get name, or GPA, get GPA, set GPA, set score, set address, get address. This is by, again, the name can be any name you want, but by convention, that's the name. And that's more understandable because when I'm going through a class and I see get name, I know this is a accessors method to get an instant variable. So it will return the name. So mutators restriction. Here they say the use of mutators give the class designer the ability to restrict client's options to modify an object state. So that's mutate, to be able to change the value of the instant variables. So I may use a constructor to create an object. As time goes on, I may say, okay, the instant variable of the object, I want to change it. Then I can use the set method or the mutator. So a mutator is often designed so that the values of the variables can be set only within a particular limit. here with me, for example, if I have a class name clock, actually we have that example already in the object-oriented programming classes, writing classes lecture. We had a class name clock. I have an instant variable hours, minutes, a second. The setters, we had a if condition that the, let's say, set minutes. We want the minutes to be between 0 to 59. When it's greater than 59, we increment the hour by 1. So it is to set the limit of the value. And again, we will see this in Unit 5 when we implement it. So we have a quick check here. Why was the face value variable declared as a private in a die class? This is the previous lectures. We had a die class program. And now the question is, why was the face value variable declared as a private? The whole concept is for encapsulation, again, to make sure the face value is an instant variable. Instant variable is the variable in the class level, the class variable. Always it should be private to enforce encapsulation security. So they say by making it private, each die object controls its own data and allows it to be modified only by the well-defined operation it provides. So other classes outside this class cannot modify it or cannot directly access it. Now, why is it okay to declare mass as public in the die class? A mass is a constant, and remember, a die, we have a limit. The values, the face value can be only from 1 to 6. So we just have that variable to set the mass to 6 for us. So its value cannot be changed. Therefore, there's no violation of encapsulation. We declare it as a final constant, and we assign 6 to it. So this will be the end of our short lectures on encapsulation. I made this lecture because students asked about the concept of encapsulation. We already discussed this in our previous lectures, writing classes. When we are writing a class, always encapsulation comes in because we declare the class data members as private so that it will be secure from other classes to directly access it. And that's what we call encapsulation. So again, wish everybody the best and thank you. You can comment on this video, like, and also subscribe. Thank you.